Okay, it looks like we're live. Hello and welcome into my channel. I am Professor L, and I'm hosting this a stream for math tutoring. So if you're out there in YouTube land and you are needing some help with your math, you're welcome to come join me. I am going to be here this week for sure, Monday through Friday from 6 p.m. to 7 p.m. Central Time. So if you want to come hang out with me any day this week, and you can ask me whatever math question you want to ask me. It could be simple math or it could be more complicated. It doesn't necessarily have to be the subject that I'm on right now. What I'm doing is I'm just hanging out here just in case someone needs some help. And so, yeah, and in the meantime, just trying to stay busy. And right now, I'm working on a system of linear equations with four unknowns, and I still haven't really solved it yet. And so sometimes persistence pays and sometimes it doesn't. So I'll go ahead and get right into it. Again, happy Monday. I hope everyone's doing well. So, all right. Reflecting on Friday, I celebrated a little too early because I maybe it's the time of day or maybe it's the pressure from being on camera. I'm not really sure what's going on, but I messed up two different places. So what I want to do is I want to try to actually get the solution, verify that it's the solution, and then probably end the stream there, and then maybe tomorrow try to pick it up again. I did try to solve, I spent some time working on this one in my spare time, and I realized the Gauss-Jordan elimination method is the best method for solving a system of four unknowns, much better than the inverse method. Your calculator will calculate the inverse, and you can also plug these into AI, and it will calculate these inverses for you very quickly. But calculating the inverse of a four variable system, it turns out it's a pretty daunting task. Like it's completely ridiculous. Like you have to come up with a matrix of cofactors, and that in itself, you're literally asked to compute the determinant of 9 different, or I say 9, I think it's 12 different, well, no, 16. It would be 16 mini determinants to get the matrix of cofactors alone. So while I do want to do it eventually, it was just very daunting, very time consuming. So I realized that we have Gauss-Jordan, and it's probably the most practical way of solving one of these. I was also kind of toying with the idea of possibly solving one just algebraically. This one has got a couple equations here that don't have all of the variables. Like if you notice, the fourth equation only has 2, and the first equation only has 3. So if there was a way for me to quickly eliminate, it might be practical some systems to solve algebraically, but really I'm figuring out that Gauss-Jordan is a good solid method. So I do want to eventually solve this one on my own. However, what I'm going to do is I'm going to start by recalculating this inverse because I have one digit off. I put right here, I put a 0 instead of a 1. How silly is that? And then the other mistake is right here, where I multiplied 2 times 3. Instead of putting it over 15, I put it over 5. Like just really, if I made a mistake and it was like a complicated mistake, then it would be one thing. But those are just ridiculous mistakes. And so what I need to do, I beat myself up because it's tragic for me to watch this on Friday, watch the mistakes, and then let it sit there all weekend without it being corrected. So I just need to start being a little bit more careful. And yeah, those mistakes are tragic when you do them on camera. And anyway, even if I wasn't on camera and I was just doing them on my own work, maybe I just need practice. It could be the time of day as well. But anyway, oh well. Nothing I can do about it now. So let's go ahead and redo this one. We'll name this one A. And we're going to go ahead and augment this matrix and just list in the coefficients. 3, 6, placeholder for Y. Wait, 3, 6, 0, -3, and then 3. And we got 1, 3, -1, -4, -12. We've got 1, -1, 1, 2, and 8. And we've got 2, -3, 0, 0, 8. Perfect. Draw the line here. This is just distinguishing between my coefficients and my constants. And then re-entering it into the calculator. What I want to do is I want to get the solution. We're going to go ahead and call B inverse math 1. Let's try that again. Second matrix 2 inverse math 1. Enter. Perfect. So let's go ahead and write out the A inverse. And it's a little bit different. 1/2 -3/4. And then we've got 1/3 -1/2 -11/6 15/4 5/6. I did not realize I was covering that much of it up when I was writing. -7/4. All right, so this one is, yeah, -3/4, 1/2. That one value changed every value in this matrix. So I was wondering about that. -1/2, 0, 19/4. 19 does not look like a 19. -7/4. -3/2 and 1/2. All right, perfect. Now what I'm going to do is I'm just going to call a matrix. We're going to do all of this on the calculator real quick, and then we'll verify the solution. And what I mean by verify is once we have values for all of these, like this is wrong. So once we have these values, I want to plug into the system and make sure that each one of these solutions here, W, X, Y, and Z, it must satisfy each and every equation in your system. So like the one before, whenever I recalculated the inverse, I solved it again with the Gauss-Jordan elimination, and I thought I had the solution pretty good, but what happened was it verified some, but not all of them. So I know that the system, even recalculating it, I didn't do it correctly. So these are challenging, and we just have to stick with it. So we're going to go ahead and call a matrix. I just want a 4 by 1. So we'll go edit 4 by 1. And then I'm just going to list the coefficients. No, the constants now, not the coefficients. So I have the coefficients here. I'm going to list the constants. 3, -12, 8, 8. All right, so then what I can do is I can multiply these. I'm literally just going to multiply like I did before. We did it by hand on Friday. I celebrated too early because I actually found 2 errors. And what I want to do today is I want to get the actual solution, verify, and then come back and recalculate it, making sure that I've done it correctly. I don't know if that makes sense. All right, so second quit. So what I'm going to do is I'm going to say second matrix 2 negative. And then I'll do second matrix 1. Let's see what it does. Perfect. Oh, except for I forgot to ask it to give it to me in fraction form. Okay, so it says that this will be W, X, Y, Z. The solution should be 17 divided by 2, 3, -49 divided by 2, and 27 divided by 2. So I was just trying to see if any of the values were correct, and they're not. They're all wrong. So it's fine. All right, now that we have the actual solution to the system, what we can do is we can take each one of these equations and plug in, okay? And verify that it's the actual solution, because you have a unique solution. Unique means there's only one of you. You're one of a kind. You have a unique fingerprint. Each system will have a unique solution. So there's only one W, one X, one Y, one Z. And according to my calculator, we've got 17 halves, 3, -49 over 2, and 27 over 2. So what we're going to do is we're going to see, let's see if this is the actual solution. So we'll just take the first one, we'll do it here. So we got 3 times W. So we've got W is 17 over 2. You can also do this in the calculator as well, but never hurts us to do a little bit of algebra. So get a better marker here. Plus, oh, that one's completely dry. Hang on. I'm going to try one more time. Okay. So it's plus 6 times 3 minus 3 times Z, which was 27 halves. And that's supposed to equal 3. So let's see if we can get this to equal 3. So 17 times 3 is that 51. Okay. So we've got 51 halves plus 6 times 3 is 18. 27 times 3 is 81. So minus 81 halves equals 3. So what we're going to do is combine these fractions. We've got 81 minus 51 is 30. It's negative. So 30 divided by 2 is 15. So we've got negative 15 plus 18 equals 3. And look, this one checks out. 18 minus 15 is 3. So we found it satisfies 1. So 1 down, 3 more to go. So let's just see if we can fit 1 in here. I'll try to write it smaller. So we've got W 17 halves plus 3 times 3, and then minus a negative 49 halves minus 4 times z, which is 27 halves. And this should equal negative 12. And we'll just see negative 12. Put a little negative in there. And I guess my markers decided to try out over the weekend. I don't know. I have some good ones in here. All right, so let's just see here. We got 17 halves plus 9. This will turn into a positive 49 halves. And then we're going to have a negative here. 27 times 4. I'm getting 108 divided by 2, and that should equal negative 12. All right, so we're going to combine our fractions. They have the same denominator, so it shouldn't be too bad. 108 minus 17. I'm getting 91. 91, it's negative. And then we've got to figure out this 9, plus 9 here. Wait, we have 4. We get in a hurry. All right, 49 plus 17. Let's try this again. And then minus 108. Okay, so now this is 9 minus 42 halves. So 42 divided by 2 is 21. Minus 21. So 9 minus 21, is that 12? Yay, it does. It checks out. Okay, so we've got negative 12 equals negative 12. So this one is looking like we did find the solution. Let's go ahead and finish it. So we're going to check the third one now. So we've got W, which was 17 halves. I don't know why I can't just like make sure I'm completely prepared for these live streams, but it's whatever. All right, 17 halves minus 3 plus negative 49 halves plus 2 times z, which is 27 halves. And this should equal 8. Perfect. So let's see what we got here. Let's see, 17 halves minus 3 minus 49 halves, 27 times 2. I'm getting 54, so plus 54 halves equals 8. So what I like to do is combine the positives first and then deal with the negative. So we've got 54 plus 17 is 71 minus 49. So this is going to be negative 3 plus, wait a second. Let me try this one more time. Okay, we got 54 plus 17 minus 49. Okay, 22 halves. Oh, divided, it's 22 halves, so that's 11. Oh, okay, I think we got it again. So 11 minus 3 is that's 8. Good. All right, so look, it's looking like we have the solution. We have one more to check. It's a small one. It's 2w minus 3x. So we've got 2 times w which is 17 halves, minus 3. This marker. It'd be time to get more markers out. 3 times x. So the x was, was 3. It was the whole number. And that should equal 8. So we've got 17 times 2. Oh, that's easy. Those cancel. So that's 17 minus 9. Hopefully, and that is 8. Perfect. So we've got 8 equals 8. So this is verified. This is the solution. And so what I want to do next, we'll probably go ahead and end there because it's been an extremely long Monday. And yeah, just want to stay efficient. I really feel confident that I can solve this now using the Gauss-Jordan. I really want to solve a 4x4 Gauss-Jordan method. So what I'll do is you can actually find the inverse too using Gauss-Jordan as well. So do I want to do that next? Yeah, we'll just decide. But we did finally get the solution to this one. It was not as easy as I thought it would be. And yeah, we'll just cut it short today, which is fine with me. I hope that you all have a great rest of your Monday, and I will see you again tomorrow. I'll go ahead and sign off there. I'll say bye for now, and I'll see you all next time.